Here it is, the episode that was missed on this channel, the Coral USB Machine Learning Accelerator performing inference on Ubuntu machine. Get us started by following the tutorial by Google. The Coral USB Accelerator adds a Coral Edge TPU to your Linux, Mac or Windows computer so that you can accelerate your machine learning models. The advantage of the Coral over the NVIDIA machine learning devices is that Coral draws much less power, thus you can run your models on a battery-powered devices such as Raspberry Pi for instance. To get started, we will download the Edge TPU runtime and PyCoral library. Then we will run a TensorFlow Lite model on the Edge TPU. Let us also take a brief look at the USB Accelerator datasheet. The Google Edge TPU Machine Learning Accelerator can perform up to 4 TOPS, which stands for trillions operations per second. TOPS is a way to quantify the capability of a hardware device to perform a large number of mathematical operations per second, which is crucial for training and deploying machine learning models efficiently. Hardware accelerators such as GPUs, TPUs, for instance this Coral USB accelerator, and dedicated AI chips are designed to deliver high TOPS values, enabling faster training and inference times for machine learning models. Our accelerator has the USB-C 3.1 connector and is supported by various operating systems. You may ask, what is required to run some of the examples provided by Google? I will be using Ubuntu Fossa 20.04 LTS, since Coral development environment is compatible with this version of Linux. But you could use the older version 18.04 according to Google. Our Edge TPU is even compatible with the Raspberry Pi OS. I do have one USB-C port available in my Ubuntu machine. In a future episode, I will also connect the Edge TPU to a Raspberry Pi. It is the time to install the Edge TPU runtime. Open the terminal and first update and upgrade all libraries on your Ubuntu. This time around, let us not upgrade Ubuntu to the latest version. To check the version of your Ubuntu installation, type lsb_release_-a. I checked and I know that the examples that Google listed in this tutorial run with no issues on Ubuntu 20.04. I will install the entire runtime in a virtual environment to shield the OS from the different libraries that we will install today. This is my 20th project, therefore, I will create a directory project 20 and set up the virtual environment there. Go ahead and cd to this new folder and start your virtual environment. You will recognize that you are in the virtual environment by the name of your folder in parentheses on the left-hand side. If you are on a compatible version of Linux, go ahead and copy each line and paste it into the terminal. These commands are all listed in the YouTube description below this video tutorial. Now install the Edge TPU runtime. Since I already have these libraries installed, I get a message that nothing has changed on my machine. Now is the time to connect your USB accelerator to your machine using the provided USB cable. If you already plugged it in, remove it and plug it back in. Just so you know, there is an option to install the TPU runtime with a maximum operating frequency, an equivalent to overclocking your CPU on your computer. This process increases the inferencing speed, but also increases power consumption and causes the USB accelerator to become very hot. Unfortunately, you cannot have both versions of the runtime installed at the same time, but you can switch by simply installing the alternate runtime at will. In step 2, we will install the PyCoral library. Copy and paste the following command. Again, I already had it installed, therefore I see no changes on my machine. In step 3, we are ready to run the inference on the edge TPU. We will classify an image of a bird with the MobileNet version 2 model to see if required libraries are all in place and to check out our new purchase, the Coral Edge TPU. First, we will be creating a Coral directory and downloading an example code from GitHub, which may take several seconds to complete. Now is the time to install some requirements. Download the model, labels, and the photo of a parrot from Google. The moment of truth. We will now run the image classifier with the following parameters: model, labels, and the input image with the use of Edge TPU Accelerator. If everything works as it should, we will see a similar report to this one: the time it takes to perform an inference on this image. The Python script performs the inference 5 times in a row, with the first one taking the most of the time, since it also accounts for loading the model into the memory. As a result of this classification, Google's parrot was identified as Aramacao with the confidence score of 0.76. Go ahead and execute the following command in the terminal. The first problem. In our environment, we are missing the module NumPy, responsible for numerical computing and essential in machine learning projects. We will successfully install it with pip. Let us try again. Now we get a message that we still need the Python imaging library PIL module. It is responsible for handling and manipulating digital images. We will simply install Pillow with pip, which should resolve the dependency issue. Okay, let's try again. And another issue. The PyCoral module seems to be missing. If you do get this problem, go ahead and follow instructions dedicated to Mac OS on installing the essential library. Trying again to classify our bird. Oh no, another issue. This time around it was my fault. I did not hook up the Edge TPU to my Ubuntu machine. Okay, plugged in. I have the strong feeling that everything will work perfectly from now on. It worked! my report is generated. 5 inference times, the longest being over 15 milliseconds, and once the model is loaded into the edge TPU's RAM, the inference times are as short as 5 milliseconds. Our image was correctly classified with the same confidence score as Google's. This score is a number that varies between 0 and 1 for 100% confidence. Hope yours was classified as well without additional issues. Congratulations! This time around, we will not go over the Python scripts used for image classification. With your Coral Edge TPU and the following projects, you could build interesting, intelligent devices. As a reminder, these examples are not compatible with the DevBoard Micro, since that device runs on a different operating system. The image recognition with video sounds particularly interesting right now. This section contains multiple examples showing how to stream images from a camera. These streamed images undergo classification or detection with TensorFlow Lite API. Each example uses a different camera library such as gstreamer, OpenCV, pygame, and pyCamera. Let us now explore this short tutorial on Edge TPU simple camera examples. These examples are compatible with your USB accelerator as well as the Coral dev board if you have one. We have already installed the runtime environment for the Coral USB accelerator, so that is done. Make sure that you do have the latest TensorFlow Lite runtime installed by following one additional comment. Copy and paste into Ubuntu terminal the following. Next, make a new directory and cd into it with this command. Then get the following repository. cd into examples camera and download the models with the following shell script file. These TF-Lite models will end up in a folder called all_models. You will also download some text files with the labels for your detected objects. For all the demos in this repository, you can change the model and the labels file by using the flag --model and --labels. Also make sure to use the models labeled _edge TPU, as these are compiled for the accelerator. Otherwise, the model will run on the CPU and the inference times will be much slower. For classification, we will be able to choose from 9 different models, with the last 3 dedicated to birds, insects, and plants. For object detection, we can choose from 3 Cocotte datasets, the last one devoted specifically to face detection. Canned models are often trained on common machine learning tasks, such as image classification, object detection, natural language processing, NLP, and so on. They are trained on large datasets, resulting in models that have learned to recognize patterns and make predictions. The term canned implies that these models are ready-made and come in a standardized format, making them easy to use with minimal setup. Users can simply download the pre-trained model, load it into their code, and start making predictions relevant to the model's domain. Let us first explore the GStream camera example project. In the detect Python script, we are shown how to use it correctly. The default command is pretty straightforward. One can also specify various parameters, and for me right now it is important to specify the camera ID. The lid of my laptop is closed, and I have an external USB camera hooked up at the moment. Thus, I cannot use my default built-in camera. Running this command, I can explore the IDs of any cameras currently connected to my machine. The Video for Linux 2 provides an interface for applications to interact with video capture device. I have two cameras, integrated and USB webcam. For the webcam, I need to specify the ID before I can use it with any of these Python scripts. You can install it by running the following command. However, if you do use your built-in camera, go ahead and use the simpler command. In my case, however, I will use the extended command simply because I need to change the camera ID. Here lives our detect.py script. And now comes the moment of truth. An error popped up, no module named GI. Let me try to resolve this by installing the following. Just like me, you may already have some or all of these libraries, but it doesn't hurt to try anyway. Trying to stream again, and another bummer. This time around it complains something about a video convert. Thus, let me trim this command to only what is necessary. Hey, and now I do see myself. Hello everyone, it works. It looks good. There are red bounding boxes, one around me, my waving hand, and some books in the background. I am being recognized at high confidence score within around 13 milliseconds. That is fast. Now press Ctrl and the key C to exit this script. Just checking what happens if I input 0 for my camera ID. Just as expected, I do see a blank screen since the laptop's lid is closed. The default model used in this example is the TF-Lite MobileNet version 2 compiled for the Edge TPU. We use the COCO, which stands for Common Objects in Context, dataset labels. COCO dataset is commonly used for object detection, segmentation, and captioning tasks in a computer vision. It was trained with tens of thousands of images. With the model flag, we can specify another model to be used as well as many other parameters. The labels, the number of categories to show during an inference, the source of the video stream, which we have just applied, and the input video format. By default, the format is set to RAW. Let me change the model to face detection only, This way we won't see any books in the background. And here it comes. As you can tell, this is me, with no books in binding boxes behind me. The inference time is even shorter than before, just above 9 milliseconds. And now let me play with the Raspicam project. We do not need to clone the repository again, we can simply start the Python app, cd one level up, and enter the Raspicam folder. Install the PyCamera with the bash script, and a bummer. The error message says, unable to determine if the system is a Raspberry Pi. We will simply put the project on a back burner for later on, when I get some time to record a video with the Raspberry Pi and the Coral. So what other projects can we explore today? Perhaps the pygame example? Just like a moment ago, no need to clone anything. Let me enter the correct directory. I also have the models in all models directory. All I need to do is to enter the pygame folder and install the libraries used in this example. Be patient because it will take a few minutes. Google asks us to set up the display first. And again, we will use the Coco dataset compiled specifically for Edge TPU devices. Let me peek into the runtime options for this app, and I'm looking specifically for the ability to change the camera ID. Perhaps it will work right off the bat. But no module named pygame was found. This module contains a set of libraries designed for writing video games. Pip will take care of that deficiency. Trying again to run this app, and I have connected to the laptop's camera by default, which is not good for me. In the meantime, I have done some research, and now I know where to look into the code. If you need to, make the necessary changes in line 69 as shown on the screen and save your Python app. A couple of seconds later, the camera image emerges with objects shown in bounding boxes and the confidence scores. We are also flooded with the amount of information in the background. Here we will find the name of the detected object, the confidence scores, inference times, and frames per second. Every single object is listed per inference. In this line, for instance, the app was able to detect 1 person and 3 books per event. The inference times are similar to what we have seen before with this Edge TPU Coco dataset model and hover around 13 milliseconds. Let us now explore the OpenCV example project. I need to CD 1 level up. Now enter the examples camera and then OpenCV directory. Traditionally, I need to install the requirements and look how to change the camera ID. Here comes the flag I was looking for, the camera_IDX. Back in the terminal, enter something is happening, and it works as well. The available menu is somewhat expanded to what we have seen before. What do we have here? 4 arrows that do not seem to change anything. Oh, a strange looking matrix came up on the screen. The zoom in and out buttons. The save screenshot button. And a copy image button. The inference times are not shown, but with a small modification of the app we can change that. That is all for now. Keep exploring and have fun. See you all soon again. Ciao!